This mini lecture is going to be dealing with how to create packages in Ada. Now, a package is similar to a record, except it groups more than just simple or more complex data types that you specify. A package allows you to group related functions and procedures in records all together in one particular place. Instead of just having one mega file that stores everything, now you can break your program down into separate pieces and functionalities and allow this. So for this example, we're going to create a package called points. And a point, as we looked at last time, is just a record that, in this case, we're going to have an x and a y value. If we added in a z value, it'd be a three-dimensional point. And we can also add in a create point function that's going to take x and y as an integer value, and it's going to return point. So we're creating some functionality that say, well, you pass me some information, I'll give you a point back. And if we wanted to go on with this, we could have, like what we saw in our previous video, and go through and have a line which would contain a start point and an ending point. And then we could also go in and have a create line, and the line would take sort of our starting point and our ending point of type line, and this would return a line. So we could go through and create a set of functionality that it is related to just points. Now, for now, I'm going to comment this out because of time concerns. We're just wanting to look at how we can work with this with just one specific piece, and that's a particular point. Now, if you notice, I have a semicolon here. Now, typically what you've seen is you go through and then you would say is, and then you would define what this particular information is. However, with Ada, we don't do this. This is what's called a specification file. And if you note, this is stored in an ADS file, not an ADB file. So this isn't something that can be run through and it's not going to completely execute by default. And we have to define this create point function somewhere else. And in this case, I have a package body points is, and then we have our endpoints, and then I'm going to have a function create point that's going to take x and y as an integer, and this is going to return point, and I'm going to say this is, and then we'll have our begin, and then we'll have our end, create point, and then we will have a var of type point, and then we'll say var.x equals the x value entered, and var.y is going to be the y value that's entered, and then we are going to return the variable. So this is our simple create point function. Now, unlike our typical Ada programs, this doesn't execute by itself, but we can compile it to make sure that we have not made any syntax mistakes. So I can make this, and it does give us a warning because it typically thinks that it should be lowercase even if we make it uppercase. That can be safely ignored. Now, to use this, we have to go back to our typical program where we have a specific procedure instead of a package, because a package is just like a function in Java. It's typically not executed, or it's usually not executed at all unless you specify it to. The exception being the static void main. Now, I can't just go ahead and magically start using points in this. I have to say with points. In this case, I'm going to use an uppercase. And then I'm going to use the points package. Now, if you notice, it's very similar to these previous ones, except I don't use the eta dot. And it's important that you don't create the eta dot points because that will cause this to not work very well. So I'm going to say I'm going to have a point P, and then I'm going to set P equal to, say, whatever this procedure that I defined returns. Now, I can go through and then output this information using our standard output tools. So this will create a point at the location 3, 4, and it will be stored in that particular record, and then that record will be returned and stored, or the values will be copied over to P, and then I will go through and output the information. So instead of compiling points, now we can compile example 1, and we have the point 3, 4. So this has been an example of dealing with packages and the fact that we can group all of the information about points in this particular file, and we can specify here is the functionality that is specified, but not exactly how this works. So I could go through and specify several different types here, and then specify all the functionality for them. And if I wanted to use them, I could just simply refer to them in my main procedure file. Now this is, in one sense, it's nice because I can use this file as a place to define, well, this allows users to have 2D points in their program. It contains useful mathematical libraries as well. So we could go through and have line detection procedures or functions. We could have line creation. We could add in the grid concept to this. All sorts of things about points could be stored in this, are described in this particular file, and then we would have to go over to our actual package body to implement them. And this documentation can clue us into exactly what's going on with this. So if I'm trying to figure out how to use a particular package, I just look at the specification, and it tells me the types that are there, and it tells me the functions, the parameters that are going in, what's going to be returned. It's all a nice, neat, compact summary, and we're not cluttered by any of the implementation of said functions and procedures. And depending on what's there, that can actually make a pretty big difference, because one of the downsides to reading Java code just by itself is you have to look at both the functions and their methods and all of their implementation all at once. There's no way to separate them unless you use a tool like JavaDoc, which goes through and records each class and the methods for that class and describes it in an HTML page. Ada was invented before this particular style what came into vogue with programming languages, and like C and C++, you typically have what are called header files, in this case a specification file, that describe what is possible for this particular quote-unquote package in Ada, instead of mixing the two together and then requiring another tool to produce this information. So these can be quite useful. However, there are a few disadvantages to them as well, because when you think about it, if I have to change this so that I make a change in this file, and then I have to update the change in package body. So for some reason I go through and I'm wanting to use floats, Instead of this, I have to make sure all of the changes are made in points in the specification, and then I have to go through and make sure they're changed in the specification or in the body, because if I just change it in one place, there's going to be a compile error. So there are benefits and downsides to this dual file approach. And one of the other downsides that we're seeing is exactly what I'm having to do with this text editor, is switch between different files. And this editor is not well designed for this, whereas something like Eclipse is better designed for handling multiple file projects. So just a couple of points to consider, no pun intended, about Ada and packages.